we've been talking a lot about interior angles, but exterior angles is something that you might want to consider in questions as well. So if I draw a polygon, just a portion of a polygon, we said that an interior angle is the complete inside angle at every corner of a polygon. And an exterior angle is if you extend any side with a straight line, it's the angle between that extended line going back to the original polygon. So, for example, let's grab another colour. So if I extend this side here, then the angle made with the original polygon, that's an exterior angle. Okay, similarly over here, etc. Now let's turn this into a hexagon. So what I'll do is I'll put a line over there, a line over there, and a line over there. And let's draw every exterior angle actually. So let's extend this line over there, we have over there. Let's extend that line. E, all of these are exterior angles. Similarly with a regular and irregular polygon, where interior angles are all the same for regular, it's the same with the exterior. It follows. If all the interior angles are the same, and we established that an interior and an exterior each add up to 180, if all the interior angles are the same, then all the exterior angles are the same. Okay, so what I'd like you to do is to work out, using the similar methods that we've discussed, can you work out what each exterior angle is here? We are considering exterior angles specifically for a regular polygon. So if I were to tell you that this is a regular hexagon, for a regular hexagon, I would like you to work out the value of each interior angle. So pause the video, spend a couple of minutes doing that. Okay, so hopefully you've done that. You've worked out the value of an interior angle of a regular hexagon. We've done this quite a few times by now, so I'm going to go through this quite quickly. There are 6 sides. We do 6 minus 2, which is 4, times 180 is 720. That's the total value of the interior angles, and we divide that equally with the 6 angles. So there are 720. Okay, divided by 6, which is 120. So if I just label one of them, just any, because they're all the same. If I label this one over here, if that's 120, then the exterior angle must be the remainder up to 180, because we said in interior, this is a straight line. So if that's 120, then the exterior angle must be 180 minus that, which is 60. So this value of E, which because it's regular, they're all the same, is 60 degrees. And notice if you add up all those exterior angles, remember 6-sided shape, hexagon has 6 exterior angles. Well, if you were to add up all of them, what does it make? 60, 60, there's 6 of them, 360. Ah! So maybe there's an easier way of getting, without going through that whole process. In a regular polygon, all the exterior angles will always add up to 360. I did it for a hexagon, but it works for any polygon. So, like we discussed, we established that an exterior angle is 60, which we could have seen because we established that the exterior angles add up to 360, and there's 6 of them. So we could say that that came from 360 divided by 6. So we come up with the following formula. Now the following formula is as follows. An exterior angle, this is 1, not the sum anymore, this is just 1, is 360 divided by the amount of sides. However, I want you to be careful when we use this formula. Unlike n minus 2 times 180, to be the sum of the interior angles, that works for regular polygons and irregular polygons. This only works if it's a regular polygon, because I can only take 360 and divide by the amount of sides, because they are all the same. So So I can just take, I know they add up to 360, I'll just divide by how many there are. But in an irregular polygon, all the exterior angles will be different. They will be different. So this doesn't make sense to have a single formula for an exterior angle. They're all different. If it's a regular polygon, then you can use this formula. Now, E is one exterior angle. N, when we use this notation, don't have to use it, it just means the number of, instead of writing the number of. Okay, it's the number of sides. Now you can rearrange this formula by switching these around. So I could also write this as the number of sides is 360 divided by one exterior angle. Now sometimes what happens is in an exam question they'll give you a polygon and they won't tell you how many sides there are. Everything we've done up until now, it's all been nice because I've told it's a hexagon or an octagon or a pentagon and maybe a heptagon, a nonagon, decagon, whatever it might be. But if they tell you that, then you know how many sides. I can take away 2 times by 180. If they suddenly give you a polygon where you don't know how many sides there are, and I don't really want to get into sort of heavy algebra with ends and things like that, well, this is the way to go. Because if I need to know the number of sides, I just do 360 divided by each exterior angle, assuming it's regular. And remember, an exterior angle won't always be given to you. The easiest way to get an exterior angle is find an interior angle. And remember, the interior angle and the exterior angle are related because they're 180 minus each other. Now, if that was all a lot to take in, I'm now going to summarise all the formulae. We've now done all the formulae for this topic. Okay, so what I'm going to do now is put a list of all the key formulae. Very important to write this all down. This is the grand summary. Everything I'm about to write down is everything you need to use to answer any exam question on polygons, because we're at the end now. Okay, so we said that the sum of all the interior angles is n minus 2 multiplied by 180, where n is the amount of sides. That works for any polygon. You can always use that. Doesn't matter if it's regular or irregular. That's number 1. Number 2, even before that we said any exterior angle plus its corresponding interior angle adds up to 180. So this is quite useful if you want to flip between interior and exterior or vice versa. If you have one, you just do 180 minus the other. And that can be used in conjunction with formula number 3, which says 360 divided by the number of sides, that n is the same as that n, gives you one exterior angle, an individual exterior angle. However, write this down, this is only for regular. If you've got an irregular polygon, you should not be using that. You must not use that. This only holds for a regular polygon. But we said sometimes you want to rearrange it, okay? Because this, an alternative form of this formula, just by simple rearranging, is that 360 divided by one exterior angle gives you the amount of sides. I feel that sometimes it's more appropriate to use that form in terms of most exam questions, the harder ones. They want you to know how many sides there are in a certain polygon. And if they want you to know how many sides there are in a certain polygon, all I need is an exterior angle, if it's regular. How do I get an exterior angle? You need to get an interior angle, depending on what information you get. You need to get an interior angle. Then you can use this to get an exterior angle. Once you have an exterior angle, you can use this formula to get n, which is the number of sides. Right, okay, this is an interesting question. I'd like you to draw this and write this down, including the information. Because, again, I want for your notes that you can see the question, the information that's given. It's an exam template question that you can look back on and use for the work that I'll set. So here we have part of a polygon. This says the diagram shows a regular polygon. It's being a bit nasty. It's not telling you how many sides, it's just telling you it's a polygon. This is part of a regular polygon. But if it tells you it's regular, highlight that. That's important. That makes our life easier. It means we can use formula number 3. It means 360 divided by the amount of sides is an exterior angle. It also means all the interior angles are the same. It gives us options. Right? We know it's a regular polygon. It says the interior angle, which they've labelled I, is 7 times the exterior angle. Okay, that's it. No values, nothing. That's all they're telling you. How many sides does the polygon have? So can you get that down? I'll just read it out once more. The diagram shows a regular polygon. The interior angle is 7 times the exterior angle. How many sides does the polygon have? I've given you all the formula for this topic. There's nothing more I really need to say. So I want you to have a go. Have a go before I do it. Press pause, copy this down, rewind if you can't read a word because I've recited it, and you need to find how many sides the polygon has. It hasn't drawn it for you. It hasn't drawn the rest, so how are you going to get the amount of sides? So press pause, have a go, and then let's see if you get it right. Okay, let's go through it. So where do we start? How many sides? Well, we're thinking, okay, the formula I just told you for sides is n is 360 divided by the value of one exterior angle. But I don't know what that exterior angle is. Okay, so maybe if I get the interior angle, well, I don't have the interior angle either. If I had the interior angle, I could just do 180 minus that, 360 divided by that, and then, well, that's done. So perhaps there must be something else. There's no values here, so I have to start with something outside of what we've been discussing. And that's this sentence over here. The interior angle is 7 times the exterior angle. So let's put that into maths. The interior angle, well, that's I, is 7 times. Well, that means I must be 7 times the exterior angle, I and E. But what can I do with that? So what you need to recognise is that, as we said before, the interior and exterior are related. They add up to 180. Now, if I is 7 multiplied by E, I can now replace I over here with 7 times E. In algebra, we would just say 7E. So now, together, they add up to 180. It's both now, I've replaced I with 7E. So I can say 7E plus this E, add them, and force it to be 180. Then I'm going to get an exterior angle. So I've run out of space at the bottom. I'm just going to go in this corner. So I'm going to say 7E plus another E is 8E. But together they must add up to 180. Every individual interior with its corresponding interior, okay, interior and exterior, has to add up to 180. So this becomes 8E is 180. Okay, which means that E is going to be 22.5. Don't be alarmed if you get decimals as exterior angles. Not a problem. So the exterior is 22.5. Now, I haven't actually answered the question. I've just used that fact. If I was 7E, then automatically it means I can get the exterior angle. Did I want the exterior angle? Not really, but it's going to help. Because now we say, how many sides does a polygon have? Well, remember that formula. The amount of sides, n, is related directly to the exterior angle. Now let's say I'd worked out the interior angle, which you could have done. You could have written E as I over 7. And it would have been harder, but you could have done it that way. Remember, once you have the interior angle, if you want the amount of sides, remember you could just convert to the exterior angle by doing 180 minus. So, to get the amount of sides, you just use the formula n is 360 divided by one exterior angle in a regular polygon, but we know it's regular. And 360 divided by 22.5 is 16. Which means this polygon, in fact, has 16 sides. So maybe you understand why they didn't draw all of it. Okay, it's a 16-sided polygon.